For the reaction rate, rate of reaction means about how fast a number of moles of one chemical species consume to form another species. So it means if A producing B, so it means how fast number of moles A consume to form product B. Okay, so the definition is number of moles of A reacting or disappearing per unit of time, per unit of volume, or in the unit of mole, okay, over the decimeter cube per second. Okay, so this is the definition, and this is the equation. Negative RA equals to 1 over volume V, dNA over dt, N stands for mole. Okay, so it's a rate of reaction, therefore it must be over the time. And okay, this is also the rate of reaction or disappearance of A. Negative RA depends on temperature and composition. So the rate equation, rate law, or it also can be called as rate equation. So just now we have rate of reaction. This time is about rate law. Okay. So the rate equation, which is rate law, is an algebraic equation that's solely a function of the properties of reactive materials and reaction condition. It is independent of type of reactor. So reaction rates are related to the concentrations of substances involved in reactions as quantified by the rate law of each reaction. So if we have A, the reactant of A producing B, okay, so the rate law is negative RA equals to KCA in terms of concentration. So concentration that we are talking about is concentration of your reactant. Okay, therefore the equation is negative RA equals to KCA, which K is the rate constant, or also can be called as specific rate. Okay, specific rate. So rate constant K for nth order reaction expressed as, so this is the unit. Okay, the expression for rate constant or specific reaction rate. Concentration, this is power 1 minus n. This is the symbol. This is the equation actually. So we have mistakes here. Concentration, power of 1 minus n over the time. So the unit of K became mole over decimeter cube, power of 1 minus n over the second. So it depends on which order of reaction that we are talking, that you will dealing with. If it's 1, so 1, if n equals to 1, so 1 minus 1, so it became 0 at here. So concentration, power of 0 over the time. So what will you get? Okay. Relative rate of reaction, single phase reaction. So this is example of single phase reaction. We have A plus B producing C plus D. So the small letter of A is representing the stoichiometric or mole stoichiometric for each of the substance that we are dealing here. So reactant A, for reactant A we have small letter A, the stoichiometric for reactant A, plus small letter B, how many mole of B, okay, how many mole of C being produced, okay, how many D being produced, okay. So if we assume A has been completely consumed, completely react, okay, so or we call it as a limiting reactant. So we use A as our reference. So if A has been used completely, so it means A divided by A, okay, so everything is divided by how many mole of A, okay. When everything is divided by A, so we will get A over A, so equals to 1, okay, B over A here, C over A here, D over A here, okay. It means every mole of A consumed or disappearing, it means every mole, all of mole of A, 100% completely being consumed or disappearing. The C over A, moles of C produced or formed. Okay, the same goes for this. So for every mole of A consumed, D over A, moles of D being produced or formed. Okay, it's just the same. And then we'll see how does it relate to each other. So this is relative rate of reaction. Okay, so rates of reaction of all material are related by negative RA over A equals to negative RB over B equals to RC over C equals to RD over D. So if you can see from the signage at here, for reactant we have negative because it is disappearing. Okay, for product, okay, we have positive because it's being formed. Okay, therefore it is positive. Okay, but we don't put the positive. Okay, don't forget the negative sign at here. Negative RA over the stoichiometry of A. We have A. Negative RB over how much mole of B being used. Okay. C, D for the product. Okay. So the rate of disappearance. Okay. So as you can see, this is equals to this equals to this equals to this. Therefore, negative RA over A also equals to RD over D, also equals to RC over C. Okay, so because everything is equal. Okay, so how can we relate it to each other? So if rate of disappearance of A is also being called as negative RA. Okay, rate of disappearance of A. If you want to know rate of disappearance of B, it will be RB. Okay, negative RB. So if you want to know the relationship of rate of formation of C, which is RC, okay, how does it relate to RA? Okay, RC over C equals to negative RA over A. Therefore, RC equals to negative RA over A multiplied with C. Okay, can you do it on your own? Okay.